Number 5. So here we're looking for this distance over here, and keep in mind that this is not necessarily drawn to scale. So the first thing we're going to do is a free body diagram. So I'm going to draw the bar over here, and there's going to be the weight of it acting at the center because the bar is uniform, and then there's going to be this mass here that's exerting a force, and I'm going to draw it more to the right just because we don't know exactly where it is. There's going to be a tension over here, and over here there's going to be an upward force and a force to the right. You can think of this as the friction force and this as the normal force. But we don't care about these forces because we'll pick the pivot point to be here anyway. So we go ahead and label our forces. We're going to have F1, F2, and F3, and our distances as well. R1, R2, and R3, which is the whole bar here. So let's go ahead and define everything. R1 is going to be half of the length of the bar. This is going to be 5 meters. R2, we don't know what it is. That's the X. And R3 is the whole length of the bar, which is 10 meters. Let's define our forces. F1 is going to be the weight of the bar, which is 66.5 newtons. F2, we have a 10 kilogram mass, so it's going to be the mass times G, so 10 times G, which is 98 newtons. And F3 is the tension, which is given as 177 newtons. So we sum up the forces, set them equal to 0. F1 is going to produce a clockwise torque, so negative F1 R1, F2 as well, minus F2 R2. F3 will produce a counterclockwise torque, but you have to be careful because F3 is not perpendicular. So what we really need is this force here. This would be F3 perpendicular. And it turns out that it's opposites of this angle. You could draw it here as well. I don't like to draw it here because I like to keep it at its R value. It's at a distance of 10 meters. If you put it here, you might start to think that it's closer to the pivot point than it really is. But this shows you that it's the opposite component, so it will use sine. So F3 perpendicular is going to be F3 sine of our angle times R3, and that will be 0. And we are just trying to solve for R2 in this case. So R2 is going to be negative F1 R1 plus F3 sine theta R3 divided by F2. We have everything defined over here. Plug it in and you should get 10 meters.